So hopefully you've had time to complete both 2 and 3. And 2 says this, bottle C contains 150% of the water in bottle B. How much water is there in bottle C? So bottle B, we determined, had 16 ounces of water. And bottle C is going to contain 150% of that, which means 50% more. Well, 50% of 16 ounces, of course, is 8. So if we add 8 to 16, we end up getting 24 ounces of water in bottle C. Now, that's not the only way we could do it. As a matter of fact, I'd love it if you share with me some ways that you might have approached it, or send a picture of the work that you did, or through Google Chats, Google Hangout. Any one of those is a good way to share. Bottle D, on to number 3. Bottle D contains 12 ounces of water. What percentage of the amount of water in bottle B is this? So again, we're going to start with bottle B, which is 16 ounces, and a D has 12 ounces. So it appears to me that this amount is 4 ounces less. 4 ounces less than B. And 4 ounces, when compared to 16, of course, if we did that, 4 over 16 is 25%. That's 25%. So it says, what percentage of the amount of water in bottle B is this? So 12 ounces would be 75% of bottle B, 75%, because 4 ounces is 25%. So we could check that and make sure that that's true by taking our 12 and put that over the 16 ounces. And if we convert that to a percentage, we just do exactly what the fraction bar tells us to do. Divide 12 divided by 16, and that's going to be, that will end up being 0.75. Excellent. Okay. Now let's move on to representing a percentage problem with an equation. We're going to do these together, boys and girls. So answer each question and show your reasoning. Is 60% of 400 equal to 87? Answer the question, show your reasoning. So let's have a look. Well, I know that 50% of 400 is 200. And so 60% can't be 87, because a percentage that's less than that is 200. And we can figure out exactly what 60% of 400 is. And we could use our 10% rule if we wanted to. We could convert our percentage into a decimal if we wanted to. And that's the way I'm going to choose to do this one. I'm going to take 60% and I'm going to convert it to a decimal. And as in decimal form, it's simply 0.6 or 0.6. Remember that of, boys and girls, almost always means multiplication in mathematics. So 0.6 of 400. So it's just the same as saying 0.6 times 400, right? 0.6 times 400. And 0.6 times 400, well, 6 times 4 is 24. And then, of course, I factor back in my 2 zeros. Really, it's 100, right? And then I have one decimal position here. So this tells me that 240 is 60% of 400, so not 87. And it's that. So the next question is 60% of 200 equal to 87? Well, again, 50% of 200 is 100, so it's still too big. But again, we can figure out what it is. So 0.6 times, or 6 times 2 is 12. And then, of course, we have the 100 that we have to factor back in. And we have to place our decimal. So 60% of 200 is 120. Now remember, boys and girls, we could have done this using our 10% rule. And you might remember the 10% rule, which is pretty simple. I'm going to use 400 as the example here. So if we have 400 and we want to know 10% of that, we simply divide it by 10, which means we shift the decimal one place to the left. So that's 40. Well, 6 times 40, of course, is 240. So if 10% of 400 is 40. 60% of that is 6 times that, or 240. We could do the same here. Shift a decimal, one place over to the left. 6 times 20 is 120, which is exactly what we came up with when we converted the percentage into a decimal and multiplied. And finally, it says, is 60% of 120 equal to 87? Well, this is a possibility because 50% of 120 is 60. So again, we're going to use the 0.6, and we're going to multiply it by 120. And of course, 6 times 12 is 72, and I'm going to factor back in the 10 that I took away. And then I have one decimal position here, none there. So I come up with 60% of 120 being 72. So the answer for each of these is no. So let me just confirm by checking my work. And remember, boys and girls, if you find me making a mistake, which I'm sure to do at some point, you get a prize. And I believe the current prize for this week and possibly next week is that you get to sleep late and possibly come to class in your pajamas. But I have to clear that with Mr. Snyder and Mrs. Melita before we confirm that. So let's go back to this problem. 120, 10% of it, of course, is 12. And 6 times 12 is 72. So that works out just fine. All right. Okay, number 2. Let me erase some of this. And also, I want to experiment a little bit with a board that I have. So bear with me for that as well. If you can't see it very well, do let me know. Oh, I should try black to see if that works better. Let's see if that's a dry erase marker. That might work better. Let's see. I probably need to get the windows closed for the shade. Okay, that doesn't work as well as I'd like it to. Okay, 60% of x is equal to 87. Write an equation that expresses the relationship between 60% x and 87, and then it says solve your equation. So 60% of some number, 60% of some number, I'm going to put a question mark because really that's the same. The variable is a question mark. In this case, we're calling it x, is equal to 87. So I'm going to write that equation. So I see 60% of x. Well, of always means multiply, so I'm going to put the x here, equals 87. So I'm going to convert the 60% into a decimal. It's quite easy to do. I get rid of the percentage symbol and I divide by 100, so it's 0.6. So this amounts to 0.6 times some number equals 87. Well, I know if I divide this side by 0.6, that factors out to 1. And therefore, I have to do the same thing to the other side. I have to do exactly the same thing because of that equal symbol, right? So I have 87 divided by 0.6. 87 divided by 0.6. We did this in our last unit. So I don't want to divide by the 0.6. We can do it, but it's going to be a little bit confusing. So I'm going to shift the decimal one place to the right, which means I have to do the same thing to the dividend. And then I just divide. Well, this is going to be a 1. And then we're going to have 27. And 6 can be subtracted from 27 4 times. That's 24. 3 times. And I have to buy some more space here, boys and girls. Okay, so we have 30. Oh, isn't that nice? Prep for success. 6 can be subtracted from 30 5 times. So the number I come up with is 145. 145, and that's for number 2. And now the other two problems, well, 3A and B, right? There are 2 sections of them. And boys and girls, I'll be perfectly frank. I don't mind you using a calculator on some of these problems. This unit is really about understanding expressions and equations and how they can interact, how they can help us, how we can model situations using them. So really, it's not about the computation, but rather being able to express things using equations and expressions. And you'll see that very often they're very concise and helpful for us in doing certain things. So, number 3, write an equation to help you find the value of each variable. So 60% of C, so I'm going to convert 60% to a decimal, 0.6. Of C means multiply, so just 0.6C equals 43.2. So I just have to now divide both sides by 0.6. If I do that, this side factors out. That's just going to be 1. And 1 times C, of course, is C. And this becomes 43.2 divided by 6. Now remember those equations from lesson 5, those complex equations? Why did I put a 5 there? Because I said lesson 5. It's not what I wanted. I wanted 0.6. Oh, I can use different colors. Just realized that. So 0.6. This is a correct answer. It is a correct answer. So I'm going to do this one out, but the next one we'll do using a calculator. So we have 43.2.
You're using Zoom?
Divided by 0.6. And again, I'm not going to divide by 0.6. I'm going to multiply both the you can think, remember, I think in terms of fractions when it comes to divisions. I let that one slip. But we're going to multiply both the divisor and dividend by the same factor of 10. So 10 times 0.6 is 6. 10 times 43.2 is 432. 6 can be subtracted from 43 7 times.
Are you all done painting? Almost.
And 6 can be subtracted from, what in the world am I doing, boys and girls? That's a 2. I put down a 6. Okay, here we go. So this is a 2, sort of. And 6 can be subtracted from 12 twice. And of course, again, prep for success. So we're done with this one. So it's 72. 60% of C is 72. Well, I mean, 60% of 43.2 is 72, which can't be, right? It can't be. Because 60% of, oh, wait, I'm sorry, 60% of C. So C is equal to 72. So that's right. So that works. And then you would put it back into the equation and see if it works. And we can do that checking with a calculator. We'll do more of that a little bit later. So let's do B. And whoops. Let's do B using a calculator. And you can use any calculator you want. I'm going to use the one on my phone, and it becomes very helpful. But I am going to write the equation because that's really what the lesson wants us to be able to do and what this unit wants us to be able to do. So 38% of E is 190. So again, I'm going to convert the percentage to a decimal. Quite easy. I get rid of the percentage symbol, divide it by 100, which means it's 0.38. And it's of E, so it's just E, right? When I don't put any space between a number and a variable, it means multiply, is 190. Okay, so I'm going to take my calculator, open it up, And I don't know if you'll be able to see this. I'm really testing at this point. But again, what I'm going to do to both sides is I'm going to divide by 0.38. And I'm going to divide this side by 0.38. So obviously this number is going to be larger than 190, correct? It's going to be a little bit more than twice as much. I know that because 190 divided by 0.5 would be 80 more than 190, or it would be 270. So this is going to be a little bit larger than that because 0.38 is a little bit smaller than 0.5. So in my calculator, again, I don't know if you can see this or not. There we go. I guess you can. In my calculator, although it's going to be reversed for you. In my calculator, I'm going to put 0.38. Whoops, that's not right. Let me clear that out. I'm going to take 190 and then divide by 0.38. And I get 500. 500. So I get E is equal to 500. Now I want to ask myself at this point if whether or not that makes sense. So let's take a look. 38% of some number is 190, and 500 does in fact make sense because if I put here 500 and I said, okay, what's half of 500? Well, half of 500 is 50%, and that's 250. So that would be 750. But this is 38%, so I would expect it to be a bit less than that, right? So that works. It certainly seems like it's the correct answer, and of course it is. The other way I can check, boys and girls, is I can take 0.38 and multiply it by 500. And that equals, sure enough, 190 when I put it in my calculator. Of course, you're going to see that in reverse, I think. So that's the way that works. Okay. Now, what I'd like you to do is carefully read through the lesson summary, and then I'd like you to give the practice problems 1, 2, 3, and 4 a try. That's going to take a bit of time, and please check those on the longer video that I upload, Mr. Morgan's videos. You don't have to watch all of Mr. Morgan's video because we did most of that together here now. What I would suggest you do is you just fast forward through the video to get to the practice problems. You can also do that, boys and girls, if you have trouble with a practice problem, because he literally will talk you through it. And so we're going to do 1, 2, 3, and 4. Please do that in your math notebook or in your remote folder. And then please complete the exit slip. And the exit slip is usually won't take you very long, but I do, obviously the exit slip is going to be a lot easier once you've done the practice problems and checked your answers. And so that becomes pretty easy. If you have any questions, by all means, Google Hangout me, Google Chat, send an email. Any one of those mechanisms can work. I hope you guys are staying safe. I hope you're well. And once you've done that, the practice problems, check the practice problems, then go ahead and do the exit slip and submit that to me. Thank you, boys and girls. I hope you have a good day and a nice evening.